There are two kinds of equations that we've learned so far. We've learned standard form, which is ax plus by equals c, and we've learned slope-intercept form, which is y equals mx plus b. But there's a third kind we haven't talked about yet, and that is a kind called point-slope form. And point-slope form, perfectly named because it's used when you have the slope and just a point. Now, a question you might be wondering is, if there is a form that we can use when we have the slope and just some point, not the y-intercept, why did we spend so long learning how to take an equation with the slope and a point and put it in slope-intercept form? Why didn't we just go straight to point-slope form? Why bother doing slope-intercept form in the first place? And the reason why is because point-slope form looks like this. It is y minus y1 equals m, and then in parentheses, x minus x1. That is point-slope form, and that's one of the reasons why we maybe prefer slope-intercept form sometimes. But point-slope form is a good tool for us to use every now and then, especially because it's a really easy way to get an equation if you have the slope and a point, which we do in this case. It says we've got a line that passes through 3, -2 with a slope of 1/4.
What are you doing?
I'm recording a video.
Say hello.
Yes, you can come say hello.
Oh.
The whole family's in here.
Hello.
All right.
The whole family. Mom.
All right. So here's the x and the y that we're going to use, and here's the slope. Now the slope obviously is m. The confusing part here is that the 3 and -2 is going to be our x1 and y1. It's not x and y, it's x1 and y1. Just like slope-intercept form, even when we're finished with everything, still has a y and an x in it. It's like y equals 3x plus 4. When we write our final equation, it still has an x and a y. Point-slope form is the same way. It's still going to have an x and a y in it when we're all done. Dude, you are really messing up my handwriting here. Okay. So, still going to have a y and an x in it when we're done. So here's what we're going to do. We're going to do y minus, and then we're going to put our y coordinate in, which was -2. Thank you. Equals, and we're going to put in our slope, which is 1/4, and then in parentheses, x minus our x coordinate, which is 3. And there's our equation in point-slope form. Hopefully it bothers you a little bit that we have minus negative. Let's go ahead and fix that. Y plus 2 equals 1/4 x minus 3. And there it is. There's the equation in point-slope. You may see that we're not too far away from being able to turn this into slope-intercept form. If we did the distributive property with the 1/4 and then subtracted 2 on both sides, we could put it in slope-intercept form if we wanted to. We're not going to, but we could. Okay, so how do we graph this? Easy. To graph it, we need 2 points. The problem gives us one of them. The problem tells us it goes through 3, -2. So there's that point. And the slope is how we're going to get the other point. Our slope is 1/4, so we do a rise of 1 and a run of 1, 2, 3, 4. So rise of 1 and a run of 4. Oops. And then we'll use our ruler to connect these points. And there's our line. So there's our equation in point-slope form, and there's our line. What do you think, bud? You get all that?
Daddy,
Mm-hmm.
tell me if the chair is hotter or colder.
Okay. I'll take that as a yes.